Hi everyone, we're back with practice problems from Module 1. The first one says convert 1.2 milliliters into liters. So I wrote our conversion, our metric prefixes here. If we want to convert from milliliters to liters, then we're going to move our decimal point toward the left. So we have liters would be here, our base unit for volume. Oh wait, we're going to move right. So we're going to, no we're not, we're going to move from milliliters to liters. So we're moving left. So you could just say 1.2 milliliters. Oh, I need to move my decimal point from milliliters to liters. 1, 2, 3 places. 1, 2, 3 places. I put my decimal point there, fill in the zeros, so I get 0.0012 liters is equal to 1.2 milliliters. Or you could do it by setting up the factor label method. You could write 1.2 milliliters, and then you could write a conversion factor. 1 liter is equal to 1,000 milliliters. Then milliliters will cancel. So you just do 1.2 times 1 divided by 1,000. And if you need to type that into your calculator or just move your decimal point when you're dealing with thousands, you would still get this answer. Since milliliters canceled, you're left with liters. So two kind of approaches to the problem, but the same thing. All right. Number 2, convert 34.50 kilometers to meters. So if we have 34.50 kilometers, we start here at kilometers, we want to go to meters. So that's, well, this is millimeter, this is meter. So our base unit this time will be meter, it'll go there. Kilometers to meters, so we'll go 1, 2, 3 places to the, I can't tell my left from my right that way. So 1, 2, 3 places. So we'd have 34,500. Our decimal place would go there. Except we wouldn't write it because that's not a significant figure. So we'd have 34,500 meters is equal to 34.50 kilometers. You also have to consider significant figures in this problem because before I did all that, my 34.50 kilometers has how many significant figures? 4. 1, 2, 3, 4, because the 0 after the decimal is significant. This 34,500 only has 3 significant figures. We need to keep all 4 of our significant figures. So we need to use scientific notation to express this number properly. You know, with scientific notation, you write all of your significant digits, but you always just have the ones place. Everything else would go after the decimal point. And then we'll multiply by 10. So here we'd go 1, 2, 3, 4. If we want our decimal point to be here, we'd have to multiply by 10 to the 4th. So we have 3.450 times 10 to the 4th meters as our answer, because that's the only way to express the number 34,500 with all 4 of the necessary significant figures. Alright, so problem number 3. Convert 0.045 kilometers to centimeters. So we're going to go all the way from kilometers to centimeters. That'll be 1, 2, 3, 4, 5 places that way. 1, 2, 3, 4, 5. So then if I wrote that, I write 4, 5, and I put a 0 in each of these. And that would be centimeters. So I'd have 4,500 centimeters. My initial number, 0.045, had 2 significant figures. This 4,500 centimeters also has 2 significant figures. So this answer would be correct. We don't need to put it into scientific notation if we don't want to, although we could, and that would be 4.5 times 10 to the 3rd centimeters. So either of these answers would be correct. They both express two significant figures. Okay. Number 4. If an object has a volume of 34.6 milliliters, how many kiloliters of space does it occupy? So we're converting, so in this case, we're talking about volume, so our base unit will be liter. We have 34.6 milliliters, and we want to convert that to kiloliters. So that's the whole way. 1, 2, 3, 4, 5, 6 places this way. So 1, 2, 3, 4, 5, 6 places. We get a 0 in every little bump. So we'll have point. I always put that placeholder 0 in front of the decimal so I can see 1, 2, 3, 4, 3, 4, 6 milliliter, or not milliliters anymore. We've canceled out milliliters and converted to kiloliters. So that still has the same 3 significant figures that it needs, and that's fine. So decimal point 40 is 346 kiloliters. You can do that the factor label method way also, and that's just fine. Number 5, a box is measured to be 2.3 meters, so width, by 4.2 meters high, by 3.5 meters long. What is its volume in cubic centimeters? Now, I have lots of people miss a very similar problem on the test by just saying 2.3 times 4.2 times 3.5 is this number of meters cubed. And then they just say, oh, and then a meter cubed is a liter. And that is not true. We talked about this in class also. Not true. You need to convert your distances from meters to centimeters before you try to find the volume. So instead of writing that our box is 2.3 meters by 4.2 meters by 3.5 meters, I'm going to change all of those to centimeters. So 2.3 meters is going to be, if I cancel out, if I have meter here, centimeter here, I know that there are 100 centimeters in 1 meter. So if I multiply 2.3 by 100, I get 230 centimeters. So I can do that for each of those distances, which is really easy. Then to find volume, of course, I'm going to just multiply all 3 of those numbers. So my volume will equal length times width times height. Always write your equation. Very important. It keeps things orderly. And when we get into more complicated problems, you'll be glad when you take this step by step. So in this case, volume will be 230 centimeters times 420 centimeters, because that's what 4.2 meters would be in centimeters. And the other measurement, 3.5 meters, so that would be 350 centimeters. So when I take my calculator and I multiply all 3 of those, I find volume to be, well, I have to consider significant figures. Each of these figures has 2 significant figures, so whatever your calculator says, you need to round that to 2 significant figures. In this case, that would be 3.4 times 10 to the 7 centimeters cubed. So you can write centimeters cubed as cm with the 3 exponent, or you could write it as cc for cubic centimeter, which the book does sometimes. But you know that either way you write it, it's a cubic centimeter, and that it equals 1 milliliter. So that means the volume really is 3.4 times 10 to the 7 milliliters. But what is the problem asking for? You have to be careful. It says, oh, what is the volume in cubic centimeters? Well, that's easy. It's 3.4 times 10 to the 7 cubic centimeters. If it asks for the volume in milliliters, you would just have to know that cubic centimeters are equal to milliliters. If it asks for the volume in liters, though, then you would have it in milliliters. You could just convert. You could say, I know that 1 liter is 1,000 milliliters. Divide this by 1,000, and then you would have 3.4 times 10 to the, reduce that by 3 and get 4th liters. But that's not what it asks for. Make sure you read the problems carefully. And make sure when you take the test to look at the back page of the test. Sometimes there are problems on the back page. I don't know about test 1, but just check. I've definitely had people turn in tests that are not complete because they didn't look at the back. Okay, so that'll be maybe the toughest problem on the test. There's one very similar to that. So make sure you read it through and convert from meters to centimeters before you try to find volume, or it will be tough. If you just do it and then try to convert after you do the math, it doesn't really work unless you're very careful. A nurse injects, this is number 6, 34.5 cc's of medicine into a patient. How many liters is that? So we have 34.5 cc's, which equals 34.5 milliliters, because we know a cubic centimeter is a milliliter. It's asking here how many liters is that? So we could do our conversion, 34.5 milliliters. If we want to convert milliliter to liter, we'd go, our base unit liter, 1, 2, 3 places in this direction. 1, 2, 3, put our 0, so we have 0.0345 liters. That keeps our 3 significant figures, and that works. Or you can do the fraction method there. Number 7 has part A, B, C, and D. If you have any questions, feel free to call me. I'll just tell you the answers. I find A to have 5 significant figures, B 4 significant figures, C has 2, and D has 4. And number 8, it wants us to write some numbers that are listed in scientific notation in their decimal form. So A is 6.54 times 10 to the third. That would be 6,540. That's A. B, that's 3.450 times 10 to the negative third. That would be 0.00345. Oh, that's a terrible 0. Hold on. And yes, this end 0 is important, because if it's listed at the end there in scientific notation, that means it is significant. So this number is significant all the way out to this place. That 0 counts for something when it's put there in scientific notation. For C, this is number 8. 3.56 times 10 to the 7. So that'd be 35,600,000. And part D says 4.050 times 10 to the negative 7. And I'll actually show you this one, how I would do it. So I want to show this as 10 to the negative 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and put my decimal point. Put a 0 in every single one of these little bumps. There should be 1, 2, 3, 4, 5, 6 zeros. And I did it right. That's good news. Then I'd put my place holding 0 right there. So I'd have a 0, a decimal point, and then 6 zeros, 4050. Hopefully you can see this well. I've got a better camera going this time. And I learned today, fun fact, your front-facing camera shows all writing in mirror images. So clearly not a good choice for math, unless you read mirror writing really well. Okay, so this is problem 9. Lead has a density of 11.4 grams per milliliter. If I make a statue out of 3.45 liters of lead, that's volume, what is the statue's mass? Okay, so in this case, I want to take density and volume and find mass. So we know that there's a formula here. Density is mass divided by volume, right? The Greek rho here, density is mass divided by volume. We know that to be true. We know that we have our density, which is 11.4 grams per milliliter. And we also are given the volume, which is 3.45 liters. Okay, so you can see already that we have a little unit crisis. We have milliliters here and liters here. They won't be able to cancel each other out unless we convert one. So let's convert the liters to milliliters. So we know if we go from liter to milliliter, we're going to go 1, 2, 3 places that way. 1, 2, 3. So that's going to be 3,450 milliliters is the volume of our statue. So then we can just plug in here, or we could solve for mass first. If we want to rearrange this equation, which many students find to be easier to rearrange first and then plug in. So I'll do that this time. We want to solve for mass, we have density, we have volume. So we're going to get mass on one side of the equation and the other things on the other side of the equation. So if we multiply both sides by volume, we cancel out volume there, multiply that side by volume also, because you have to do the same thing to both sides of the equation. So that leaves mass by itself, and we see that mass is equal to volume times density. Mass is equal to volume times density, just rearranging that equation. So then we can plug in. Mass is going to be equal to 3,450 milliliters times density 11.4 grams per milliliter. You see here your units, milliliter in the numerator, milliliter in the denominator will cancel, leaving with just grams, which is great for a mass unit. Excellent. Then you just do in your calculator 3,450 times 11.4. Both of those have 3 significant figures, so you round to 3 significant figures, and you end up with mass equals 39,300 grams. Mass is 39,300 grams. Pretty heavy statue. Okay, so that's problem 9. And number 10. Gold has a density of 19.3 grams per cubic centimeter, which grams per cubic centimeter and grams per milliliter are exactly the same thing, so 19.3 grams per milliliter. If a gold nugget has a mass of 45.6 kilograms, what is its volume? Well, I'd like to have that gold nugget. That's a big guy. So we'll look here. You need to solve for volume. So let's write down what we know. We know density of gold is 19.3 cubic centimeters, grams per cubic centimeter. I'm just going to write grams per milliliter because we're going to find volume, and finding volume in milliliter is going to work better. So it also tells us the mass, 45.6 grams. No unit crisis here. Let's see. So we just know that density is mass divided by volume. We want to solve for volume, and so we can rearrange this just like we did before here, and that gives us mass equals volume times density, but we really want to solve for volume, so we're going to have to divide both sides by density, and we end up with volume equals mass divided by density. Volume is mass divided by density. That's probably easy for most of you, but if not, there it was. You can pause, rewind if you are confused there. Volume is mass divided by density. Density is mass times volume. Make sure I'm good. So you've rearranged. Now you can just plug in. We have 45.6 grams divided by 19.3 grams per milliliter. So if you have gram in the numerator, gram in the denominator, that cancels. Then if you have, I like to call it this way, if you have a unit that's in the denominator of the denominator, that's actually the numerator. And you can work that out and see that that's true. But if it's in the denominator of the denominator, it's truly in the numerator. So our actual unit is going to be milliliters, conveniently for volume. So then if you do 45.6 divided by 19.3, you should get 2.36 Got some problem here. What did I do wrong? I don't like this. We got a problem. Oh, I said the mass of this statue is 45.6 grams. It's 45.6 kilograms. So to convert that to grams, if our base unit is grams, we have to move that decimal point 3 places. So that's going to be really 45,600 grams. So if we change this right here to 45,600 grams, then our grams, of course, still cancel. So then we do 45,600 divided by 19.3, big difference. And we end up with our 2.36 times 10 to the third milliliters. So then that's our volume of our gold statue. Stay tuned for video 3 on the lab data analysis for Once Upon a Penny.